All right, so in this video, I want to show you how gRPC services work, how we build one, what's special about them, and yeah, let's get right into stuff. So my name is Jens. I'm one of the founders of WunderGraph, also CEO, and yeah, still love engineering, and let's go straight into stuff. So here's the tutorial if you want to follow along. So you go to the docs and then tutorial and then federate gRPC into your Supergraph. So we start with this command. So I have the Cosmo CLI installed. So here I have my terminal. That was not what I wanted to have. All right. So we get the templates and this is how we can choose which one to run. So we have a Golang template, and also I think we have TypeScript. So in this case, I just want to use TypeScript. So I type WGC gRPC-service init, and then I think the default directory is the current directory, and default template is the TypeScript one. So let's just try this out. So we're downloading the template, and now if we go to my file browser, we can see a bunch of files being created here. We also have a README, and the README tells us how to set up this whole project. So first step, npm install. Second step, npm bootstrap. That will download necessary dependencies. It will generate some code, etc. It will download WGC in the latest form. And let me see how this goes. And then final step, npm run start. Okay, so we're now generating our router execution config. We're downloading the router binary. I now run start. You can see that we have a router running and we have a service running. Our router should be on, let me see, in the config here on 3002. So let me open this port, and that's a weird query. We can query hello, name, and let's say Jens, and we query that, and we can see, okay, we get something back, it's working, hello Jens. And now we can dig a little bit into what's actually going on here, how is this stuff running, etc. So I stop this guy, I can just check my package JSON. So we have generate Proto, then generate buff, then generate router config. We have a generate function in general, and here we have start router, start service, and we have start concurrently. Okay, so I think my workflow would be to run generate and then start, but I can also just check the development. So we modify our GraphQL schema, then we run generate, we update the routes, and we start. Okay, so let's try doing that. So we go to graph schema. Here we have hello, and we just could add world, and that returns a string. Okay, so we save this. Now I would run npm run generate. It follows through all the steps. So this generates, what does it actually do? It generates the Protobuf file. It then generates the router config and everything. Okay, so if I now go to generate it and I go to Proto, we can actually see here in our Proto definition, we have query hello, we have query world, and query world response returns the string world. Okay, that makes sense. So that matches here. And then we have the service Proto definition. It has query hello, it has query world. All right, so I go to my routes, and here I should be able to say query world, and that's a function. And what does it return? It returns world, and that's a string. Okay, we don't have a name here, so let's say WunderGraph All right, so implementation done. npm run start. Now we should be able to go here. This still works. And we can add another query. And we should be able to, oh, where's my world? World is not here. Can I query it? Nope. Let me see what happened. Generate. If you look into the execution config, we should be able to see world in the schema. Type world. It's actually here. Okay. Kill port 3002. Just in case. I start it again. Let's refresh this page. Ah, okay. I don't know what was the glitch, but this is working. Cool. So then let's make it a little bit more complicated. So we cancel this. So let's do something more realistic. So we say we have products and this returns type product. It has ID, name, and that's fine. And then we could also say reviews, and here type review, ID, content. Okay, that's fine. So we generate. All right. Now you can see this is now turning into errors because this doesn't exist anymore. So now we have query products. This should be REQ. And that's wrong. We should return an object. It has products. That's an array. And inside products, we can have ID 1, name, okay, and reviews. It's an array. And here we say ID 1, content. Awesome. And for fun, we just make it a second product. Cool. So generate, we ran. Now, do I have to? No, just once. Okay, this should be fine. World is now gone. Awesome. We query products. And here we can select ID, name, reviews, and on the reviews, ID and content. Bam, our products. So you can see I've just built a GraphQL API, but I didn't implement the GraphQL API. I didn't have to figure out how to map types and everything. So this is fully type safe. And in the end, this is just a buff connect API. So we have essentially implemented a REST API, which we could also now share, or a gRPC API. Buff connect supports REST and gRPC. And yeah, you can see this is working pretty easily. And that's it for this video. So thanks for watching, and yeah, see you later. All right, so in this video, I want to talk about the topic of gRPC and how we are replacing the communication between router and subgraphs, traditionally being like GraphQL, and we replace that with gRPC, what is the background and everything. So if we look at the traditional way of how this would work, so here, let's say you have your router. So we have a router. And then behind your router, you typically have like multiple subgraphs. And in the traditional Apollo Federation world, the way this would work is you have this guy here, you have a subgraph, all right, and then you have a second subgraph. And the communication between router and subgraph, it is GraphQL. And what that means, if this communication is GraphQL, it means certain things. So the protocol, so from the client, so we have our client speaks GQL to the router. So that means the client sends text from client to server to router. The router then figures out the query plan, and next it sends text with GraphQL queries to the subgraph. And that has several implications. For example, if we have this text, what we need to do multiple times is from client to router and from router to subgraph. So that means we need to parse the GraphQL. And we don't do it once, we do it for every subgraph. So in this case, let's say we have 2 subgraphs. So this is GQL again. So we have those 2 subgraphs and we parse the GQL essentially 3 times. And just 3 times because we're making like 3 requests. But in reality, it can be like 5 requests to subgraphs. So that means it's more like 3x. But in reality, we could also just say, so if I remove this again, so it's not really 3x, it's more like nx, and n stands for the number of requests we make to our GraphQL server. Okay, so that is one part, parsing. Then we have validation. We need to validate the query. We have normalization. Okay, and then we have some other parts that are kind of critical. So let's take red for the more critical parts. Because one big problem we have with this setup is we need to do batching. So when we have a client request, let's say we want to have like the products, and for each product we want to have users. That means we need to batch this user request. Or we have products, we have comments, so we batch the comments. Okay, so that means we need to have batching at the router layer, but we also need to implement batching at the subgraph layer. So that means subgraph batching. And every subgraph has to implement this kind of stuff, and that means it's a lot of responsibility. So subgraph batching is one part, but then also we have the parsing, we have the validation, so we send the text, we need to encode the text, we send it back. So essentially it means there's a lot of overhead, and at WunderGraph we thought, yeah, there's a better way of doing that. So what we're doing is we add a new page. Dun, dun, dun. So let's add a page. So our new approach is that, and I start again with black. So new approaches, we don't actually use GraphQL, we use gRPC between router and subgraphs. So our architecture, in this case, it would be, so we have our client. The client talks GQL to our router. And then our router speaks gRPC to our subgraph. Subgraph. Okay, So if we go back to the previous page, we remind ourselves, here we had parsing n times, validation, normalization, and we had to re-implement batching or batch loading in every subgraph. So now we go to our gRPC setup, and here we have a new process. So this is what we have built. I make this in blue. So the new process is we take the subgraph SDL. So that's the schema definition language. So the description of the subgraph essentially. So we take that and we then have a compile time step here, compiler. And the compile time step, what it gives us is a Proto definition. And this Proto definition has built-in support for batching, built-in data loader. So that means we have a batching mechanism implemented in the router. So that's coming here. Batching implemented in the router, and the Proto we're generating, it already understands how batching works. And I can actually show you in a second how that works. And the second part is, in regards to the problems we had before, we had to parse the GraphQL in every subgraph. We had to validate it, normalization and everything, and then batching. In our GQL to gRPC approach, we have the client, it sends the request in GQL to the router, and then the router just sends RPC method calls to the subgraphs. So in terms of validation, in terms of decoding, there's not much overhead in the subgraphs, and it's super lightweight actually. And now I can show you where we have the advantage in terms of data loader. So I have this prepared. Let's put this to the side. And if we go to our demo here, so we can use a template and initialize this. And let me just run this guy. So here, boom, I move myself to the side. So here we have a command to init a new project. Let's do that. Okay, that's fine. Output directory is not empty. rm.gitignore. Let's try again. Okay, this downloads our template. And now let's do the example that I wanted to show you. So let's say we build a service and it should load the reviews for products. So that means we have a type product, and this has the @key fields ID directive. So that's our product. And then we want to add the reviews. Okay, it's a slice of review or an array type review. Okay, and product ID that we don't know, ID, content, and what else could we have here for review? The rating maybe. All right, that's fine. Cool. So that's awesome. We need to bootstrap our project. So that means we run npm install. Fantastic. And then we bootstrap everything. Boom. Bootstrapping, what it now does, it takes our schema, it generates a Protobuf definition, and then it does some other things. So if you look at the Proto, you can see, and this is what I wanted to show you. So we have a lookup product by ID. So you see here product, we need to look up the product by ID. So that's why we create a lookup. And then for each of the products, we return the reviews. And if you look closely, look up product by ID, here's the request. And this request, it has repeated lookup product by ID request key. These are the keys. And this is repeated, which means we get a list of product. And for each product, we can then return the results. And so with this approach, you see that the gRPC contract, it already has, it has the knowledge of batching. And that means in the gRPC service, we don't have to implement any batching. We already did that at the router side. So if I now go to my routes, this is like the hello world. And here we can implement our lookup product by ID function. So that is looking like this. We have those requests here, and then we return an object, and here we return the result. And our result, actually I think that's our slice, and in this slice we can then have ID for our product. Let's say that is the rec request. Let me see what is in the request. It is keys. And then, okay, so what we could do here is we return the result, and we do request keys. And then I think we can map this, make it the function. Here we have key. Okay, and then what do we need to return? Return an object. It has ID, key, ID, awesome. And then what else? The reviews. So now we could return a review here for this particular product. Okay, ID and rating. Content. Okay, so that's how things could look like. And again, we get a list of keys. For each of the keys, we return the data, we return our batch information, and that way we don't have to re-implement data loading here. It's all done. And yeah, coming back to what we had before. So here you can see again the architecture. So this is the Proto gRPC approach. Client talks GQL to router. Router then talks gRPC. We have this compile step that turns the SDL into Proto with our built-in data loader. Yeah, and then you don't have to worry about frameworks anymore. And the other part is this approach. It generates like a bare bones gRPC Protobuf. So I just showed you how to implement the gRPC with TypeScript, but you can use it with Go, and you can also implement that with like Java, .NET, everything that supports gRPC. It's really just gRPC bare bones. If you look at the service Proto, there's nothing specific here that has anything to do with like WunderGraph. This is really just Protobuf, and yeah, you can use any supported language. So yeah, that's my video. Thanks for watching, and see you. Ciao.